In example 1 in your notes, we have to find all the measures of the angles in these two triangles. And in your notes, right before this problem, there are two important theorems. And the one important theorem that we're going to use to help us solve this problem is the angle sum theorem. And the angle sum theorem, if you look at your notes, says the sum of the measures of the angles of a triangle is 180 degrees. That just means if you take all three angles, add them together, you will get 180. Okay? We're going to use this theorem to help us solve this problem. In your notes, you have a diagram that looks really similar to this. Okay? And we want to find the measure of angle 1. Well, we know if we take 43 plus 74 plus the measure of angle 1, let me write this a little neater. If we take 43 plus 74 plus the measure of angle 1, it will give us 180 degrees. Well, all we have to do is just get angle 1 by itself, and we know what its measure is. So we're going to combine these like terms. Okay. 43 plus 74 is 117 plus the measure of angle 1 equals 180. Then we just subtract 117 on both sides. And we get that the measure of angle 1 is 63 degrees. I'm going to write that in where 1 is, and you should do the same in your notes. We know that angle 1 is 63 degrees. We can figure out what angle 2 is without doing any sort of math. If we look, angle 1 and angle 2, those are vertical angles. They're angles that aren't adjacent, but they're formed by two intersecting lines. And we know vertical angles are equal. So we know angle 2 is 63 degrees. Okay. Now we can figure out what angle 3 is. Using that same angle sum theorem, we know 79 plus 63 plus angle 3 is going to equal 180. I'm going to go to a new page to show you to do this. So 7 plus 63 plus the measure of angle 3 equals 180. Just combine our like terms. 79 plus 63 is 142. Subtract 142 on both sides. And we get that the measure of angle 3 is 38 degrees. And there we go. Measure of angle 3 equals 38 degrees. Angle 2 is 63 and angle 1 is 63. Okay. The next example in your notes we are going to prove why this is true. Sorry. We're actually going to go to example 2. In example 2, you have a triangle. This is 55. This is x plus 74. And this is 54. And using that same concept, we know that 55 plus 54 plus x plus 74 is going to give us 180 degrees. And we can just solve for x. Go ahead, combine our like terms. 55 plus 54 plus 74 is 183 plus x equals 180. Subtract the 183. X is equal to -3. And you might be thinking, well, it can't equal a negative number. We're dealing with measurement. Well, it's okay, because if we take the -3 and plug it back in, -3 plus 74 gives us 71. Our angle at the end of the day is positive. So sometimes it's okay to have a negative x. And there you go. The directions just say to find x. So we found x. The next problem we're going is the problem right next to it. And the diagram looks something like this. Okay. Here it's 14x plus 1. Here it's 89. And here it's 5x minus 7. And again, we know all the angles of a triangle add to 180, but here's the thing. Not all the angles are inside the triangle. This 14x plus 1 is on the outside. Okay, so we can't use that method. If you look right above this problem in your notes, there's the exterior angle theorem. And it says that the measure of the exterior angle, so 14 plus 1, is equal to the sum of the remote interior angles. Okay? Well, the remote interior angles are two angles inside the triangle that are not next to or touching that exterior angle. And that's 89 and 5x minus 7. This angle right here, that's touching that exterior angle. So we don't care about that angle. We just care that it's 89 plus 5x minus 7. And then you can just solve for x. 89 minus 7 is 82. Move the 5x over. Get 9x plus 1 equals 82. Move over the 1. You get 9x equals 81. Divide both sides by 9, and you get x is equal to 9. Here we go. We found x, and that is our final answer.